Have you ever stopped to think about this massive, invisible energy drain that's happening all around us every single day? It's the incredible amount of power it takes just to keep our buildings, our homes, and our offices comfortable. Today, we're going to pull back the curtain on this hidden energy giant and explore a brilliant solution that's, believe it or not, as old as ancient history and as new as tomorrow.
All right, let's dive right in. To really get why the solution is so cool, we first have to get a handle on just how big the problem is. I mean, how much energy are we really talking about here? Just take a look at this number, 10%. That is the slice of all the energy humanity consumes that goes to just one thing, cooling our buildings. 1/10 of everything. That's an absolutely mind-boggling figure when you let it sink in.
Now, that 10% global average, that's really just the starting point, because in hotter climates, that number just explodes. This chart really shows you what I mean. On the hottest day of the year back in 2008 in Abu Dhabi, cooling buildings used over 60% of all the electricity. That's not a small jump. It's a complete takeover of the power grid. So the problem is huge, and it's only getting bigger. But what's so fascinating is that the core of a really powerful solution is, well, surprisingly old. You see, people have been fighting the heat with a very simple, very intuitive idea for thousands of years.
The whole idea is called pre-cooling. And yeah, it's pretty much exactly what it sounds like. Cooling a building before the real heat of the day kicks in. It's a strategy you probably already use without even thinking about it, right? Like opening your windows at night to let that cool air in, just to make the next day a little more bearable.
And this shows just how long we've been using this trick. For literally millennia, people in hot climates built these incredible wind towers to channel cool nighttime breezes right through their homes. And the modern basic version of that? An attic fan. It's doing pretty much the same job. It's the same idea, just with different tech.
And here's where we hit a wall. This simple, elegant strategy of using night air works great until it doesn't. In really hot climates, like in the Arabian Gulf or parts of South Asia, the nights just don't get cool enough. At that point, open windows and fans, they're just not going to cut it. So, for the hottest places on Earth, this ancient idea needs a serious upgrade, a much more sophisticated, high-tech answer to a modern problem. And this is where we get to introduce something called the low-lift solution.
So this is it, low-lift cooling. The basic idea is exactly the same as what we've been talking about. Do the hard work of cooling at night. But instead of just hoping for a cool breeze, it uses our modern cooling systems in a much smarter way.
Okay, so why is this so much better? It's really a simple two-step logic. First, you shift all that cooling work to the nighttime. And second, and this is the absolute key, the condenser, which is kind of like the heart of your AC system, doesn't have to fight against that brutal afternoon sun. It's working when it's already cooler outside, which means it can do the exact same job using way less energy.
The concept is pretty elegant, right? But making it a reality isn't as simple as just flicking a switch. It actually requires a whole new way of thinking about how we design and equip our buildings. We're basically talking about building the future, today. And hey, this isn't just some theory on a whiteboard. Low-lift cooling, combined with other things like high-performance building materials, are the defining features, they're the hallmarks, of modern green construction. We're actually seeing this being put into practice right now in amazing, sustainable cities like Masdar.
So what do you need to actually build this? Well, this here is the essential toolkit. You need cool storage, which often means just using the building's own concrete mass to hold on to the cold. You need advanced controls to manage the whole thing, variable speed compressors that can power up and down super efficiently, and things like radiant cooling to spread that coolness around. It's a whole suite of tech that has to work together.
Okay, so we've laid out the problem, the ancient idea, and this super modern high-tech solution. But what's the actual payoff? Let's get to the really good part, the truly astonishing savings. Just look at that. Seriously? The research shows that for temperate to hot and humid climates, the potential energy savings are between 60 and 74%. That is a total game changer. I mean, it's not a small improvement. It's a revolutionary leap forward in efficiency.
And it's not just for the hottest places on Earth. Even in milder climates, where you can already get some benefit from natural nighttime cooling, the savings are still massive. We're talking 30 all the way up to 70%. This is just a universally powerful idea. But the benefits go way beyond just one building's electricity bill. Think about it. By shifting that huge cooling demand away from the peak afternoon hours, these systems help stabilize the entire electrical grid. They improve reliability and efficiency for everyone, taking the strain off the system right when it's most vulnerable. This really has the power to transform how we build and power our cities. And that really brings us to this final thought from the researchers who are pioneering all this work. This isn't just about making a better air conditioner. It's a fundamental rethinking of how we live inside our buildings and how those buildings interact with the world around them. It's a fusion of ancient wisdom and modern innovation, and it's all aimed at creating a cooler, more sustainable future for every single one of us.